I should be able to solve some of these easily. So, here's aspirin. What's the pH of the solution? It should be easy. What's the equation for pH? Everybody remember?
Negative times.
Negative log of hydronium ion, right? So here's aspirin, and here's its concentration. Aspirin is an acid. It's acetylsalicylic acid. It's a whole mouthful. That's the structure of it. That's if you had a solution and that was a concentration of aspirin, what would the pH be? Would it be acidic or basic?
Acidic.
It's acidic. And what is the pH?
2.77.
2.776.
Actually, it's like
2.7.
7695.
No, we're not going all that far out. 2.78. Now, I gotta find the slide. I know I've been jumping around. I gotta put in one more slide. Let's see. We gotta talk about sig figs. Because we all love sig figs, don't we? You've been missing them, haven't you? You've been waiting for them to come back. Look, there's some stuff in the book about sig figs. I'm gonna break it down as easy as I can. Right here, how many sig figs do I have in this number right here? 2. Because it's always determined by the coefficient. The number of sig figs here tells me I get 2 here. So 2 and 2 decimal places. Okay? Not sig figs, but decimal places. Here I have 1. That means I get 1 decimal place. Okay? Same thing goes in reverse. If you start with pH 6.00, you would get 2 sig figs up here when you go in reverse. Okay? I know nobody likes sig figs. I don't like them. Okay? Because I know they aggravate my students. But just remember, the number of digits you have in the coefficient here tells you how many decimal places you get in your pH. Okay? Fair enough? Yeah, we did something other than that. All right, we did that. We're going to do reactions of acids and bases. And we're going to be done for today. All this stuff about calculating pH and all that stuff isn't very useful if you don't know anything about reactions of acids and bases. They have a picture of the lining of your stomach here. What goes on in your stomach? Your stomach produces acid, doesn't it?
Yeah.
Why does it produce acid?
Break down the
To digest your food, right? And so this acid breaks down your food, and the pH in your stomach is about pH 2. So the hydronium ion concentration is 10 to the minus 2. That's pretty high, okay? It's a lot of acid. You don't want that spilled out into your body, okay? Because most of the rest of your body couldn't handle that, okay? But your stomach, it has to have it that way. Now, acids undergo certain reactions. The first one is, or let's talk about these 3 reactions, okay? When you put a metal in acid, it normally reacts to produce a salt and hydrogen gas. We saw this in lab. You guys remember you had 3 metals that you put into hydrochloric acid. You put magnesium, zinc, and copper. Y'all remember doing that?
Yes.
What happened? You remember?
Reacted a little bit and
What did the magnesium do?
it
It foamed, it bubbled like crazy. The zinc bubbled a little bit, and the copper did
Nothing.
nothing. Okay, so not all metals react with acids to produce hydrogen gas, but a lot of them do. Bases react with acids to produce a salt and water, and we're going to show examples of these. And then the last one is carbonates and bicarbonates react to produce CO2 and water and a salt. And we're going to show examples of all these things. So here's the first one. If we take potassium and add it to hydrochloric acid, we produce potassium chloride and hydrogen gas. Anybody remember what kind of reaction this is? It's a single replacement reaction, isn't it? Look, here I have a single guy here and a pair here, and what happens? It boots the hydrogen out and the hydrogen bubbles off. It's gone. So that's fine, I'll leave you with chloride. I'm good. See you. Same thing down here with zinc. This is one we did in the lab. Zinc plus hydrochloric acid produces zinc chloride. Now these two things here are salts, okay? Not every salt is sodium chloride. Those two are examples of salts. Acids react with carbonates to do something a little bit different. Now in my lab, I'm going to show you how to figure this out. Here's my salt, right? Look at this. Calcium goes with chloride. This looks like a double replacement reaction. If it was just double replacement, I would also get this guy here. Okay? Because if I take calcium going with chloride, hydrogen with carbonate, this would be the right formula. But what happens is, this guy can't stay together, and it makes water and CO2. Okay? This is carbonic acid, and it decomposes to give water and CO2. Okay? And we did this one in lab too, when you added baking soda to hydrochloric acid. And then you put the splint in it, the wooden splint on fire, and it went out because you had all the CO2 in there, right? And that made it go out. Okay? It's a double replacement reaction followed by a decomposition, is what it really is. Because carbonates aren't very stable, they do break apart. Now the last type of reaction is called a neutralization reaction. And you get an acid and a base, and I'm going to write water differently. If I write it like this, what kind of reaction is this? It's a neutralization reaction because it's an acid and a base, but what else is it? What other kind of reaction is it? Come on, guys, we just had midterm last week. Y'all should know what kind of reaction that is. It's what? It's a double replacement, isn't it? I have two pairs on the reactant side, and I have two pairs on the product side. Why did I write water like that? Why did I break it up and write it like HOH? No idea.
Because that's how it's written in the first part.
Because that's how it's written on the reactant side, isn't it? And I can see exactly where the hydrogens and the hydroxides come from and where they go, right? So this hydroxide over here, right? The hydroxide right here came from right here. And the hydrogen right here came to here, okay? So it's just a neutralization reaction, really is just a double replacement reaction. There's nothing special about it, okay? And you guys should be able to balance these because we practice lots and lots on balancing equations. I'm not going to spend any time on this chapter balancing equations. You guys should be able to do this. And guess what? You see this section here, acid-base titration in your book? Guess what we're going to do with it? Unless y'all want to do calculations like this. We do calculations like that? No, not really? Okay, we'll skip it. There aren't any in the homework. So on Wednesday, we'll finish this chapter. We'll talk about buffers. We'll finish up this chapter, and then we're going to do chapter 8. We'll do gases after this, okay? So we'll finish this. We'll talk about buffers, then we'll do chapter 8. And we'll be done with the chapter. The homework is up. Make sure you start working on it so you can ask questions this week, okay?